Hello students, let's talk about the programming basics in R. The objective of this lesson is that students will learn to code the basic building blocks of programming in the R programming language. So let's talk about primitive data types, or like the most basic data types that there are. Integers are whole numbers, right, without a decimal component, for example, 5. Be aware in R you have to put a capital L on the right-hand side of an integer if you want R to see it as an integer. Otherwise, it'll see it as a numeric. A numeric is a number with a decimal point, for example, 3.14. Okay. This is also called a float or a double in other programming languages if you're coming from some other programming language. Character is a data type with letters, but it could be numbers as well. It's a certain type of data type. It's called a character. Also, I'll probably refer to it as a string because that's what it's referred to in other programming languages like Python and Julia and others. So that's another primitive data type, and they are between double quotes or single quotes. In R, there's no distinction between double quotes and single quotes. In some other languages, there actually is a distinction between those two, but not in R or Python. Logical is true or false, or capital T or capital F without double quotes for shorthand. And this is referred to as a Boolean operator, or a Boolean value, that is, in other programming languages. And let's use the class. The class function is super useful in R. It helps you determine what the what the data type is. So just as an example, let me get R going here. And we will look at the class function, which can be useful to, let's just go down here. Let me zoom in quite a bit. So I'm in the console, right? The interactive console or shell, the REPL you might say, right? Read, evaluate, print, loop. If I just say class, open parentheses, 5 with no L, it says numeric. If I push the up arrow once on my keyboard, I'll get the previous command. Left arrow to get in there and do a capital L with no double quotes around it. Then it sees it as an integer, as we would suspect. Class, open parentheses, double quote, let's say apple. That's a character. Class, capital true, or capital T as a shorthand of that. We get a logical or a Boolean. I may use the word Boolean. Okay, that's cool. So I was gonna have you guys do that. We just did it together, or I just did it, and you guys watched. But yeah, the class function is super useful. It tells you what the data type is. Okay, let's talk about operators in R. We've already seen a few, and the assignment operator is probably the one you'll use the most. You may see this in R. It's a less than sign dash. For example, fruit, that assignment operator that is less than sign dash, and then a character, a string, right, of apple. This assigns this value of apple, which is a character string, to the variable called fruit. Or we could assign this vector of strings. A vector is simply a collection of many small things. And here we have 4 strings in this vector that are being assigned to this variable called fruits. And in the RStudio integrated development environment, there's a shortcut, keyboard shortcut to make that assignment operator. It is Alt Option plus the dash. Let me jump back over to here. If I were to say fruit and then Option dash or Alt dash on Windows, then it did 4 things for me. Option dash, put a space, that space right there. I'm looking at the bottom left of my screen. Let me zoom in farther for us to really look at it. And then a less than sign, and then a dash, and then a space. And then here we can put in a mango or a mango, whatever you like. Okay. Now I will point out, as I do point out right here, that you can use the equal sign as a assignment operator as well. So if you're coming from a different language and you just want to use the equal sign, that is totally fine. But you should be aware that this you'll likely see this in a lot of R code out in the wild. I will point out it's a directional assignment operator. You can see that it's kind of pointing, like this value, mango, is pointing towards this variable fruit. I could do it the other way around. If I were to say, let's say orange, all right, let's go in Spanish, naranja, and then I say dash greater than sign pointing to the right, I can put this into the variable called fruta, and that is now being held by that variable. It's kind of weird. If you're coming from other languages, that may seem kind of weird that you can actually do directional assignment operator. It's actually a directional assignment operator. If that's all Greek to you, you just want to use the equal sign, just go for it. I don't think there's directionality. Let's just try Kiwi. I'm just testing something. I don't think you can do it this way. If I just create, I'll just create fruit to, so if you're going to use the equal sign, you need to have the variable first, equal sign, and then the value. Like that. Now that's being held. But if for some reason you want to use the directional operator to the right, you need to use a dash greater than sign like I do there on this line. Naranja, directional assignment operator to fruta. Okay, cool. That's awesome. And the inclusion operator, what I'll call the inclusion operator is %, the word in, percent sign. So what this does is it tests for inclusion of a value in a collection of variables, a collection of values, that is. For example, in a vector. So here we have apple, and then we have the inclusion operator, that is %, in, percent sign. And then we have a vector, which is a collection of, in this case, strings or characters. And it returns true. So let's just look at that real quick. I will copy this over to our RStudio. And so we have a string, double quote, apple, this inclusion operator, that is %, in, percent sign, then a vector. And it says true. That means that it found this value within this collection of values because there it is. Apple's right there, the second value. But if I were to change this to Kiwi, let's just push the up arrow once and then push Control A to jump out over there. Kiwi, for example, Kiwi will returns false because Kiwi is not found within this vector of strings there. So that's false. Okay. So it's just saying, are any one of these values in this vector the one that you're asking me about right now? And it says true or false, whether it's in there or not. Okay, straightforward. Double equal sign, this is the equal operator. The equal operator lets you know if the value or the variable holding a value on the left-hand side of that operator is identical in every way to the value on the right-hand side. So for example, mango, let me just zoom in a bit more here. Let's go, here we are. Mango, double equal sign, quoted mango. These are strings, right? Double quote mango, double equal sign, double quote mango returns true because this right here, these 5 characters are identical to these 5 characters. If I were to have this here, though, if I have apple in quotes, double equal sign, and then within double quotes I have manzana, which is how you say apple in Spanish, it says false. These characters are not identical to those. And down here I have Hannah, a very common name, right? And I say, is Hannah, double equal sign, equal operator, identical to uppercase version of Hannah? And it says false. Okay, so here's a super important note. Computers treat lowercase and uppercase letters differently. Okay, so that's super important to keep in mind. We humans don't really care much about that. I mean, we just kind of, oh yeah, that's the same name. But computers see these as different things because they are lowercase, well, this is title case, and uppercase. That becomes important when we start getting into frequencies because we need to normalize our words by either pushing everything to uppercase or everything to lowercase before we calculate frequencies. Anyway, we'll talk more about that in the future. Okay, how about this here? This is interesting. What if we have an apple, in quotes, double equal sign, this is the equal operator, and we have a vector on the right-hand side. And it returns 3 Boolean values or 3 logical values. It says false, true, false. All right, quick discussion here. If you want to pause the video and think, why do you think that that's happening? Why do we get 3 values coming out of this expression? We can just try it in RStudio right now, live demo, just to make sure we're getting that same result. Yes, we are. We get false, true, false. So just speculate. Why is that happening? If you want to pause the video and think, go for it. Well, it looks like it's saying, okay, is apple equal to banana? That's false. So the first one's false. Is apple equal to apple? Lowercase, both of them? True. Good, that's why we get true as the second value. Is apple equal to mango? That's false. So we get false as the third value there in the return value. Okay, so there are some operators for you. Here's an activity you can try to use these three operators to create variables and vectors and test for inclusion of a string and a vector. Okay, so once again, just to review, we saw three operators. The assignment operator, which is directional if you use the less than sign dash, or like I showed you, the dash and greater than sign, it's directional, or you can just use the equal sign if you have the variable on the left-hand side and the value on the right-hand side, like right there, or right there. And then we saw the inclusion operator, which is the word in, surrounded by 2% signs there, 1% sign on each side. Right, it tests each one of these in turn. It says, is any one of these the one you're asking me about? It says true. So it's an inclusion operator. It says, do you find this within this collection over here? The equal operator is a double equal sign. That may be new. We don't really see that outside of computer programming. And it says, is this identical to that? But if you give it a vector on the right-hand side, it'll give you a return object for each one of the values in the vector there. Okay, good. If you'd like to try that, pause the video and give it a try for a few minutes. Okay, the next little lesson here, sub-lesson, is comments. Comments within computer code helps human readers, whether yourself at a future date or other humans, to understand your code quickly. So you put a hashtag in R, you put a hashtag and some little note, some annotation, some note to yourself of what this is doing, right? Create a vector of multiple elements, and that's pretty straightforward. This is super useful so that other people who read your code can know what's happening quickly without having to decipher the actual code bit by bit. This is more useful when you have like big blocks of code. Like this big block of code is doing this. And you give a description of what the block is doing. But you can do it for simple lines like these as well. Okay, so once again, use the hashtag or pound sign or number sign or whatever you want to call it. That's what you use to put a note or a comment. Now, I will point out that you can put it, let me actually open up scripts now. Let me open up a new file. You can actually do it like that. I'm looking up here on line 1 of my source file on the top left of my screen now. You can say, declare some variable here, and I have fruit equals sign banana, or again, I could use the kind of R-specific assignment operator like that, banana. You can also put it on the right-hand side of code. So if I were to say fruta, and then equal sign, and then manzana, you can actually put a comment out here. Declara, I'll put it in Spanish for fun, declara una variable. That means declare a variable in Spanish. So this also will be ignored. So starting with the hashtag there to the right of the end of the line, until the end of the line, it'll ignore that stuff. So this should work. Let me just double check if I were to do, yeah, that worked. And if I were to ask for fruta, it says manzana, fruit, gives me banana down at the bottom part of my screen. Okay. So yeah, you can either put it on the line above, or you can put it on the same line, but to the right of anything that's that the computer needs to read. So you can use both as well. I kind of use both of those styles of putting comments in my code. Okay, the next big important building block of programming in R and in any language is the if-else statements. This is called conditional execution or alternative execution. Conditional is the if part, alternative is the else part. Okay, so the logic is pretty simple. You ask a question, and if the answer is true, then you do something. You do this thing. But if the answer is false, then you do that thing. It's a pretty simple idea, right? So there are kind of two approaches that I'm going to show you in R. One is to use those keywords. This is the most common way that you'll see. So let's take a look at the Stack Overflow question with some R code. Let's just look right in here. So we have some variable, or let's see, we have some, this is actually a data frame, and it's asking the number of columns in this data frame. It's a matrix, actually. The number of columns in this matrix, and if that is greater than 1, so there's our question. There's our conditional statement. is the number of columns in that matrix greater than 1? If true, then you're going to run this line right there. But if that's false, then do the else clause, the else block, which says do this line, print 1 or fewer columns. So if this evaluates to true, you're going to run this block here between the first set of curly braces. Those are called curly braces. More than 1 column. But if this statement evaluates to false, then jump down to the else keyword and run this block between the curly braces after else. Okay. Pretty straightforward. Syntax is not too crazy. You just have to have parentheses around your conditional statement. That is the question you're asking. And then you have to have curly braces. Well, you don't have to, but the most common practice is to have curly braces around each of the blocks, whether the true block or the false block. That is this one or the else statement there. Okay. So let's keep rolling. Let's go back here. That's probably the most common way you'll see. A less common approach, but it's still super useful, is to use a function. There are a couple functions that are if-else functions. So let's just take a look at the documentation here on this base R function. Let's take a look here. Conditional element selection, if-else, there's an if-else function. So here's the test, right? An object that results in some logical value, a Boolean value that is true or false. If it's true, then do this. If it's false, then do this in a function form. So let's take a look at one of their examples. Here's an example. So let's say we have this, there's a vector, they're creating a vector there, x, and they're taking the square root. They're saying if x is greater than or equal to 0, just give me x. But if x is not greater than or equal to 0, that is, it's a negative number, then give me an NA. That's what's happening there, that little function. So if the if-else statements you need to write are pretty simple, just pretty small, you can use an if-else function like this one in base R. Now we'll point out that there is an if-else function in the tidyverse ecosystem, specifically the dplyr package within the tidyverse ecosystem. And the same idea. You have the condition, and you have true, false. So let's look at their example. Yeah, so here's an if-else right here, I'm looking. If x is less than 0, return negative. But if x is not less than 0, return positive. And if x is missing, then return missing. Like there are some missing values up here in this x vector that they created above. So anyway, it's pretty simple idea. You just test, ask a question or have a conditional statement. You have what will happen if it's true, what will happen if it's false, like that. Okay, so here's an activity. Create a string with a single word, and then use if-else, either a block approach or a function approach, to print to the user whether the first the word begins with a vowel or a consonant. I have a couple hints here. You can use the print function or the cat function. The substring within tidyverse is useful for this function or for this little activity to grab out the first character. Okay. Take a look at that documentation there. I have a link on it. And then the inclusion operator, the in operator, is useful here to test whether the first value that you grabbed with the substring function, is in a vector of the 5 vowels, A, E, I, O, U. Okay? So go ahead and pause the video and see if you can run this, see if you can get something like this working on your end. Ready, set, pause. Okay, welcome back. The way I'd approach this, let's create a string with a single word. Okay, let's jump back over here. I'm just going to use the top part of my screen, my little source file here. Let's just put it into a variable called first name equals Bobby. Okay. And then I need to pull out the first character. Oh, by the way, we need to import tidyverse at this point. We're likely to use tidyverse nearly every time we use R in this class. We're going to use tidyverse, just about. Tidyverse is what's called a meta package. It loads in other packages, and these are the packages that it actually loads in. These 9 packages, and there's one called stringer right there that is useful for dealing with strings or characters, right? So when we load that in, we can use it. Now I didn't explicitly point out that if you haven't installed it yet, you would do install.packages and open parentheses, double quote, and then tidyverse, and click enter on your keyboard. It'll take some time to download and install all the packages that it has, as well as all their dependencies, which are other packages that the packages depend on. So when you click enter, it may take a minute or two, or perhaps more, to install all those packages. We just do that once. So I'm not going to do that now because it would take a while. But when we want to use a function or one of those packages, we have to do library tidyverse like that. Okay, so now what we're going to do is we're going to say string sub, and I'm going to pass in the variable that's holding my string, which is first name. And you can see RStudio is hinting me. It's kind of giving me a hint. It disappeared. If I click tab, it says, okay, where's the start? I need a start and end are, where do you want me to start and where do you want me to end with this substring? I'm going to say start equals 1, start at the first character, and end at the first character, meaning just give me that one first character. And that, I'll call this first char for first character like that. Okay, good. Let me just run this and this. Now, the way to run a line to run one line in a source file in RStudio is you can, the way I do it is just Command Enter on my keyboard. On Windows, it would be Control Enter to run that one line. So if I click Command Enter right now, see how my cursor is blinking on line 8? Command Enter, it ran that line down on the console down here. And if I were to ask to see what first name has right now, down there it says I have Bobby right now. So good. Now if I want to run line 9 on my source file at the top left of my screen, again I click Command Enter and it runs it down there. It kind of copies and pastes down below into the console what I have up there on line 9, and then it runs it. So now if I say first char, I have B. So it grabbed the first character off of Bobby. So I have B. Good. Now the last part of this, we're going to need to use the in operator. That's the easiest way to do it, at least. And we just want to know whether the first letter is a vowel or a consonant. So what I'm going to do is I'm going to say, okay, if first char inclusion operator, the in operator, then a vector of I'm going to capitalize these. Like I mentioned, capitalization is important to computers. So I'm going to do that. I need to also put these within all of that except the if keyword within parentheses. Now on RStudio, you can highlight all of that and then type the opening parentheses like that, and it will surround all of it with parentheses. I don't know if you saw that. Let me show you that again. So right now I have from first char down to the end of that vector, I have it highlighted, and I do Shift the 9 key, which has the opening parentheses, and it puts all that within parentheses. Good. Then I do a space, and I do a curly brace, enter. I'll take a block approach there. So if you find the first character within that vector of those 5 vowels, then I want you to print this word starts with a vowel. Good. And then on the right-hand side of that closing curly brace, I'm going to do a space, then I'm going to type the word else, then an open curly brace, enter on my keyboard to make a new line break. So I have my cursor blinking on line 13 of my top left part of my screen. And then I'm going to say, so if this evaluates to false, then I'm going to say this word starts with a consonant. Okay, let's run it, see what happens. Ready, set. I'm going to put my cursor on line 10 at the top of this if-else block, and then do Control or Command Enter on my keyboard. And it tells me, oh, this word starts with a consonant. That is correct. Bobby starts with a consonant. Now, if I wanted to change this to Earl, it's a good name, old-fashioned name, but it's a good name. I'm going to rerun line 8. So I'm going to do Control or Command Enter. I don't need to run these. I do need to run line 9 because that's going to create a new value. It's going to assign a new value to the first char. Yep, now it's holding E. Now I put my cursor in line 10, do Control Enter or Command Enter. Now it says, oh, this starts with a vowel. There you go. So let me show you my code. My lines 8 through 14 do this little activity right there. If you want to stop the video and make it work on your end, you can take a look there. My lines 8 through 14. We don't need that other line up there. But 8 through 14 there. Okay. All right, let's keep rolling. Another very important building block in R and in every other language that I know is our loops. And the mighty and super useful for loop iterates over the elements of a collection. So for example, let's say we have fruits. Let's just grab all of this code and bring it over to our source file here. I'm going to run line 17. Control or Command Enter on my keyboard. Now it ran fruits down below in the console. I can double check that it's sitting there by typing in fruits and pushing Enter. Yep, it's holding apple, mango, banana, and orange there. And then the for loop is probably the most common loop that you'll see, that I personally see, I use. Like I said, it simply loops over each element of a collection. In this case, we're looking at a vector. I'm using the term collection as a hypernym, that is a more general term for a vector. A vector is a certain type of collection. There are other types of collections that we'll see in the future. But for loops work on other collections as well, but it does work on a vector too. So what we do here is we say for, we use the for keyword, and then we have open parentheses, and then we specify some variable name, whatever variable name we want, that we'll use below within the body of the for loop. Line 20 is what's called the head of the for loop, and then line 21 is the body. This is a very simple for loop. We're just going to loop over each element of fruits, and we're going to save the first time we have the computer go through the for loop, it's going to grab apple as the value of this variable that we called fruit, and it's going to print it. Once it's done that, it hits the closing curly brace on line 22, and it goes back up to the top of the top of the for loop, and it goes to the second element in the collection. In this case, it's mango. That's the second one. And so at that point, fruit will hold the value mango, and it will print it on line 21 again. And then once it's done that, it'll hit the closing curly brace and go back up to the top of the for loop, grab the next value in that vector, which is banana. Right? It'll save banana to that variable called fruit, and then print out banana on 21. Do the same thing with orange. Okay? So if I put my cursor on line 20 and click Command or Control Enter on my keyboard, unsurprisingly, down below, we see those four elements printed out on their own line. So even though I only wrote line 21 once, it actually ran 4 times. It ran 4 times because there are 4 elements in this collection, this vector right here. And again, so the word fruit I specify here is just kind of a placeholder for each element as the for loop is working through its iterations. It's called an iteration when it runs through the body of the for loop once. That's one iteration. The first time it does it, it uses the first element there as the value of fruit. That's why we have these printed out like that. That is the basic and most common and super useful for loop that you'll see in other languages as well. If you like to pause the video, make that work on your end. My lines 17 through 22 is what you'll focus on there. Go ahead and do so. Okay. Good. So that's what I do there. There's also a while loop, and it is, I think it's less common, at least in my experience, it's a bit less common than the for loop. It still has its place when you need it. So let's talk about the while loop. Let's take a look at an example here. The while loop It tests whether a certain condition is true or false. Okay? Remember the Boolean operators, or the Boolean values, that is, true and false? We saw this with the if-else blocks just a couple minutes ago. You say if, and then some conditional statement or some test expression. They use the term test expression on this website, right? And if that test expression or that conditional statement evaluates to true, then it will run the body of the while loop. But if that test expression evaluates to false, it won't run this anymore. It'll stop running that. So let's see if we have here's a simple example. We'll just stay right here. So if we assign the value of 1 to the variable I, and then say while I is less than 6, I want you to print out I. And then once you've printed out I want you to increase the value of I by 1. Meaning we're going to start with 1. The first time we go through this while loop, it'll be increased to 2. We'll change the value of I from 1 to 2 with that statement. And then we hit the closing curly brace, and we jump back up to the top of the while loop. We evaluate this again, and 2, right, is being held by I at this point. That's less than 6, so it's going to run this again. It's going to change the value of I from 2 to 3 with this line right there. So it's going to do that until I is greater than 6, at which point this will evaluate to false. Once I is 7, this conditional statement will evaluate to false, and it won't run this anymore. It'll just stop. That's what we see here down below. So you need to, if you use a variable, you need to update the variable or use one of the keywords called next or break. Next, both for loops as well as while loops can use these keywords. The next keyword skips the next iteration. It, like wherever you put next, it'll jump to the end of the body of the loop and continue to the next iteration in the for loop. The break keyword will just completely stop the loops altogether, regardless of which iteration it's in. Okay. So go ahead and try to do this activity. It says students create a for loop to iterate from 0 or from 1 to 10, skipping even numbers and printing out odd numbers. Hint, the modulus operator, which is 2 equal signs, will be helpful here. And here's a good example. Check if a number is odd or even in R programming. So what we can do is, here we have an if-else. We just learned this a couple minutes ago, right? And they're creating a function actually right here. But this little part right here, number, double, %, 2, double equals sign 0. It's kind of a little Greekish, so to speak. Let's just grab that though. Well, let me stop for a second. If you'd like to try this on your own, pause the video and try this activity. Ready, set, pause. Okay, welcome back. Let's take a look at it ourselves together. Here we go. So this will be important here. This little modulus operator I just copied from that website. Let's give it a number, and let's say a number equals 1. And if I run that with Control or Command Enter on my keyboard to save the value of 1 to the variable called number, and then if I run 25, having my cursor blink in 25 and do Command or Control Enter, it says false. What does this mean? This means that 1 is not an even number. This says, okay, take the number, divide it by 2, and give me the remainder. The modulus operator gives you the remainder after doing division. So I'm saying divide this number by 2, give me the remainder, and if that remainder is 0 equal to 0, then return true. Otherwise, return false. So if I change this to, let's say 6, and I rerun 24 with Command Enter on my keyboard, so that the variable number now holds 6. Yep. And now if I run 25, Command Enter, it says true. So this is a way to know if the number is integer, is even or odd. Okay. So let's jump back to our instructions, which I have right here. Students create a for loop to iterate from 1 to 10, skipping even numbers and printing out odd numbers. Okay, I didn't actually also mention that a way to do a range from one number to another number is with the colon. So let's try this. Let's do 4, let's call it, okay, open parentheses, current number, and then we do we do 1:10, and then we do open curly brace, enter on the keyboard. It pushes the curly brace, the closing curly brace down there. Good. And then we're going to say if current number, 2 percent signs, which is the modulus operator. Again, it does division and gives you the result. If you divide that thing by 2 and the remainder is equal to 0, that is, there is no remainder. Sorry, I need to put this in parentheses, I see now. I highlight it and then do Shift 9 to do the opening parentheses. If that's the case, what do we want to do? We want to skip even numbers, but we want to print out odd numbers. Okay, so if that's equal to that should be an even number. So we're going to say, just do next. The next iteration in this for loop up here. Else, meaning this is an odd number, we want to print out current number. Okay, so let's walk through this a bit. Let's just, let me just get rid of that for the moment. We don't need that at the moment. Okay, so we're going to go into a for loop on 26. We're going to create a variable called current number. It's going to go through each value from each integer from 1 to 10. That colon there is like a go from this number to that number operator, like that. And then we jump into the body of the for loop, and then we say if the current number, if you divide it by 2 and you get a remainder that is equal to 0, that is it's 0, then that means it's an odd number, right? Therefore, we want to jump to the next iteration of this for loop. So we use next on 28. But if this evaluates to false, then we know we have an odd number, and we go down to the else and we print out the current number. Let's see if that's the case. If I put my cursor on 26, which is the top of this block of code, and let it blink there, and I do Control or Command Enter on my keyboard, down in the console we see the results. It actually copied the code down there and then printed the results down here. So there we go. We got odd numbers only. 1, 3, 5, 7, 9. Okay, I'm going to go ahead and expose my code again. And you guys, if you like to pause the video and look at my code from lines 26 through 32. Make it work on your end. Okay, good. The last kind of major building block of the R programming language, as well as all programming languages, is to define your own function. It's a very useful ability, and you use the function to do that. Here is a good tutorial. Let's take a look here. Let's see what function they define in here. Okay, let's just grab a little bit of code and bring it over to an R Studio. I'm going to Control C that, Command C on Mac. Make some more more code, more space down here. So this is a Fahrenheit to Celsius converter. So the way you do this is you use the function on line 35, and you save it to some variable name, which will be the function name that you call. So they're going to use Fahrenheit to Celsius as the function name, and they're using the assignment operator, and then they use the function there to create a new function. And this right here is called an argument, and well, it's called a parameter in this case, but it is the name that we're going to use below. So whatever you use up here on 35, you need to use on 36. It could be whatever you want it to be. Like if I change this to whatever, the temp, I need to use that right there. Okay, because it's going to pass in, whatever we pass in right there is going to be used down here. Okay, let me just Control or Command Z that to get back to this point. So that's called an argument. It gets passed in, gets used right there. So apparently the way to convert from Fahrenheit to Celsius is to take the Fahrenheit temperature, minus 32 off of it, and then times it by 5 divided by 9. Okay, and that leaves you with the temperature in Celsius. And then you return out of the function the actual value. Okay, so if I put my cursor on 35 and click Command Enter, it runs it down here in the console. It didn't do anything with it because I didn't actually call the function. This right here is just simply defining the function. We only defined it so far. And we've defined it, and now it's available in our session here. You can see there. We ran it. And let me zoom out a tad bit so you can see over here on the top right of my screen. You can see that under functions now I have Fahrenheit to Celsius there, right there, about in the middle of my screen right now where I'm circling. Functions, which is below values. That's another indicator that it is ready and available in your R session to use the function. So let's actually use it. So if I say Fahrenheit, you can see RStudio is going to say, hey, are you trying to do this function? Are you trying to use this function? I say, yes, I am. And I click tab on my keyboard to accept their suggestion. And then I pass in, let's say 100 degrees. Now I understand that from high school chemistry or something, that 100 degrees Celsius, or excuse me, 100 degrees, let's do 212 Fahrenheit, which should give us 100 degrees Celsius, right? The boiling point of water at sea level. Yep. So if I give it 212 Fahrenheit, it gives me 100 Celsius. If I give it 32 Fahrenheit, that should give me 0, the temperature at which water freezes. If I give it 104, that should give me 40 Celsius, etc. So this value right there is getting passed in to this placeholder called temp F, and that value is being passed into there. So 104 is being passed into there, minus 32 off of it, times it by the result or the quotient of 5 divided by 9. And then you save that to a variable on 36, return it out of the function on 37. And then you actually call the function down here. Again, this first part was just simply defining the function, and this down here on 40 was calling it with an actual value that we're interested in. Let's try another one. Let's say, how about 80 degrees? What is that in Celsius? That is 26.6 Celsius. Okay. So yeah, this is super useful. If you want to pause the video and make this work on your end, looking at my code from lines 35 down to 40. This is how you define your own function. This will be useful when we have some specific need some specific like algorithm that we want to create. We can put into a function. Just call that function repeatedly. So I can call this again. If I do Fahrenheit, tab on my keyboard to accept the suggestion of RStudio. What is like 55 Fahrenheit in Celsius? That's 12. Looking at the bottom part of my screen, that's 12.7 or 12.8 Celsius. So we can call this repeatedly without having to type all of that code in lines 35 through 38. Whatever, I don't know what number to put in here, 72 degrees. What is 72 degrees in Celsius? 72 degrees in Celsius, 22, or excuse me, 72 Fahrenheit is 22 Celsius. Okay, so there we have it. If you'd like to pause the video, do so now. If you'd like to make this work on your end. Okay, so we are at the end of this little lesson. Here's some activities you should try if you'd like. I have a script in the Canvas course to translate from English into Pig Latin using a lot of these basic building blocks we've used here. And if you'd like to look at my code, you can look right there, click on that to translate from English to Pig Latin. You can see just quickly, we're defining a function there. We're defining another function there. We're using an if-else block here. We're using this substring function there. I'll let you look through this and make this work on your end and try and understand what's happening. And then you test the function there. Okay, so there you have it. These are the basic building blocks of the R programming language, as well as many other programming languages. And at this point, you should be able to do that. If you need to stop the video, go back, try the activities again, do so. All right, thanks for watching. We'll catch you next time.